بسم الله الرحمن الرحيم رب زدني علما.
So in the case of direct links, the convergence process is going to be 30 seconds. Like in the case of indirect link, it is 50 seconds. And whenever the direct link fails, then the convergence process will be 30 seconds. So it will go to listening and the learning states. And the default process will be 30 seconds. So the main limitation with the STP is the timers, because 30 seconds or the 50 seconds timer is, actually it was good when STP was introduced in 1990s, around in 1998 when they started. So around that time, the convergence, the applications, it's not a big deal. But in today's networks, we need to make sure that the convergence process should be much faster in general, because we cannot restrict, like 30 seconds downtime generally means it's really not good in general. So we want something faster convergence, and that's where the IEEE has come up with something called RSTP. Of course, in between, Cisco has come up with some features. These are the features which was introduced by Cisco, basically to speed up the convergence process. So we are not going to use them now, because all these features automatically comes inbuilt in RSTP. So again, a backbone fast, uplink fast are no more supported in Cisco switches as well. But IEEE has come up with something called RSTP. Now, basically, this RSTP, the name itself says it's a rapid STP, means it uses the same STP process, but mainly the difference is the convergence is going to be much faster. So the STP was defined in 802.1d, that is a standard name for STP. And then again, they have added some enhancements to speed up the process and have released with 802.1w, that is a standard name given for RSTP. So the main difference is the convergence process, 30 to 50 seconds, which is for topology change, any changes occurs. Basically, it is going to take 30 to 50 seconds, so typically. But in RSTP, it will take the maximum of 3 times of follow, which means 6 seconds is the maximum delay or the maximum time it is going to take in general. But in most cases, generally it will take few milliseconds. So it's not like it will take 6 seconds each and every time. So that is a kind of maximum time what I mentioned. But it can take an action immediately within few milliseconds. So which means if your primary link fails, the backup link or the second link automatically transitions into forwarding within the next few seconds or few milliseconds. And again, if you're running RSTP one switch and STP another switch, so basically it still supports, but again, it will fall back to the STP process. Again, that's not recommended, but it is still backward compatible with the STP if you have any of the switches. And again, it has all the Cisco proprietary features. Like Cisco initially added some of those these features to enhanced. But again, we are not going to see most of these features because most of them don't support, or we are not going to use them because anyway, RSTP have those features inbuilt in this. So by default, all the switches run STP. All the switches means, again, apart from the high-end switches like Nexus switches have RSTP inbuilt generally. But still, you see most of the access distribution level switches what we use in today's networks. Basically, they run by default STP. Okay, so by default they run STP. So you need to change the switches to support RSTP. So if you go and verify here, if I go to one of my switch, and here you can see if I go with the switch 1, like if I go to the configuration mode, or if I say show spanning tree, if I say show spanning tree, you can see by default it runs IEEE, which is a default STP process. So I want to speed up the convergence process. So basically to do that, we need to say spanning tree mode will be using rapid PBST. Okay, so we'll talk about again per VLAN spanning tree. What is that? When we mix up the concepts with the VLANs in the later on sections. So I'm saying spanning tree rapid PVST. If I say show spanning tree now, so when you say show spanning tree now, you should see spanning tree protocol is STP, RSTP. And I will go and change on all the switches. So let's go to each and every switch and do that. So when I say show spanning tree, again, I'm going to say spanning tree mode rapid PVST. And likewise, I'll go to the next switch, the switch 3 as well. Show spanning tree. I'll go and say spanning tree mode rapid PVST. Now, once we do this, if you want to verify the convergence, you can verify the convergence. Like there are few faster convergence process happens. I think, let me see who is the root bridge here, so that, okay, so this bridge is a root, which means, so in this topology, this switch 2 is a root bridge. And if you observe, this particular port is in the blocking state. So what I'll do is I'll try to shut down one of the links and verify. So I'll try to shut down this link, port number 23. I'll shut down this, which is a direct link, and I'll verify. So I'll go to interface F0 by 23. I'll say shut down. Before I shut down, I'll also say show spanning tree. I'll just keep this command. You can see this port number 22 is in the blocking state. And I'm going to shut down this port number 23. So this is your port number 22, and this is port number 23 as per my topology. And if I say shut down, before that I'll say shut down, and we'll verify show spanning tree. You can see this port number 22 is turns into forwarding state immediately. So immediately it turns into forwarding. So which means normally if you verify this, the same thing before enabling the RSTP. So this process is normally going to take 30 seconds because it will go to the listening state and the learning states. So basically now it is going to put this port immediately transitions into forwarding in this example. So likewise, let me make it as no shutdown to make this link up. And even the same thing, if you try to shut down this link as well, the indirect link. So normally this process, this blocking port will come to forwarding in 50 seconds. That is a timer. But if I shut down that link also, let's say if I shut down this link, interface F0 by 1, I think 21, that's a port. So if I shut down that link, and if you verify show spanning tree, you can see this. Let's say show spanning tree, still this particular port 22. Did I shut down the correct port? 21, yes. So this particular port, that should come to forwarding normally. So it should turn to forwarding immediately here as well. But I think it's not working in this. So it's an issue with the program actually. Or maybe the topology. So always when you try verify, basically you can try some fresh topologies. That should work normally in most cases. You can see it's not converging actually. So let me just power off the switch and power on. I think there's no power off or on option here. But basically you have to remove the cables and reconnect. That should work. So the main thing you need to understand here is whenever any of the link fails, like in the case of a direct link fails, then it will take 30 seconds. So this is no more. And if indirect link fails, it will take 50 seconds. That is also normal. So the convergence process is much faster. That is one of the main advantage with the RSTP. And of course, you have to enable something called spanning tree mode rapid PVST in most of the still access and distribution, most of the switches, you have to verify these things.